So, where did actually think so?
I'm trying to remember what you asked me.
I was asking that like the one main question right now that I have is around move closures and things being moved out of references. So I have two thoughts around this. One is this really issue with our thing or more of something we need to deal with in migration? Because
So
like
I
if
don't understand this problem yet. Oh, I see. Oh, okay.
if
Huh.
you look at the
I
move
wonder if move closures. So I think the answer to your question is your question is a good one. Is this a migration issue or not? And I guess what it comes down to is, do we expect this code as you wrote it to be idiomatic, so to speak? Like, is that the way we want you to write that code? I think
okay,
the answer is probably yes. Like, I don't think I want people to have to write let s equals s to write that closure.
which one are you talking? The first or second one? Like
I'm looking at the.
regardless of which one we do.
I guess it's the
If
second one. Yeah. The first one
okay,
is not. The first one is a. The first one
for,
is different.
first one is dealable because you can just drop the trailing DRS and we can just we're good with it. But again, the question comes down to what is the expected behavior? Like dropping trailing DRS is to get the code in the compiler today to work. But like the real question is what should actually happen?
I'm starting to wonder if move closures. I wonder if that'd be really confusing. But if move closures should not change their behavior at all, like.
Oh, sorry, go ahead.
Like you, what? So why would I say that? Because for one thing, that's where the backwards incompatibility issues primarily arise. Not
Mm-hmm.
not only because it's possible
Mm-hmm.
to move things even outside of a move closure, but primarily. And um, this example, this second example is really, I don't know. I'm kind of struggling with it. Like I don't,
Like
on the one hand, I feel like we could probably make it work, but it seems like the analysis is starting to get so complicated for what gets moved that
mm-hmm.
I'm afraid it'll be kind of magical and people won't be able to understand it.
Like okay, I'm the way I was looking at this was like assume our feature was available from day one. What would have been the expectation of that
Right.
piece of code?
And that's what I'm trying to figure out. And I'm kind of coming to the
Yeah.
conclusion like I don't know that
Like
I think it might still be that you take all the variable because
yeah.
I feel like that code should work, and that's the only way that code compiles. And if you don't, the problem is this. So we can make that code
Oh.
compile. I don't exactly know how, but let's say we
Mhm.
said something like in a move closure.
We make this kind of we introduce some level of borrowing ourselves and let's say we can get it to work. Like
I'm trying to think. Yeah, I mean, what would it be? It would be like if
we
you
would
are taking a mutable reference to something which involves a deref of a mutable reference, the
like
move closure will actually be
we
a borrowing closure. Like,
well, what I was thinking was more around, well, A, that's incorrect, right? Because if you're expecting s dot x to, let's say in this example, be moved, or because you're expecting everything to be moved, then that to be moved. Like the solution around this, I was thinking was more around outside of the closure, we add a line which is basically ampersand mute s dot x. So we have a mute outside the closure, we introduce a mutable reference to this, and in the closure, we use it. And once after the last use of the closure, the lifetime of this will kind of go away in the sense that it's not used
that's
anymore.
I don't know where we have like a hack engine, right? And it's kind of, it was kind of created for a different problem, the let underscore x equals problem.
Wait, sorry, I missed your last line. What were you saying?
I said I want to make a document where we can take notes.
Okay, I created a issue for this. Let me just add. I marked it as migrations, but if we can of course remove.
Also,
Do
sorry, can you wait 1 minute while I run to the bathroom? So danger of back-to-back calls. Hold on a second. Okay, I'm back now. So let's see. Did
Oh yeah, yeah. I have an issue for
a
this.
link or something?
Yeah, I'm gonna place that in the Zoom chat.
Great.
I
Oh,
tagged it as migrations yesterday, but we can just remove it if we feel like. Like my initial instinct was this might be that, but yeah, we can label it accurately.
yeah, I don't think it's a migration issue. I'm going to make a hackmd real quick and paste it in the issue.
Okay.
Maybe I'll share it because that way in the recording it
Mhm.
uh, you can see what I was typing when I was talking.
Mhm.
Let me move it to a fresh window so I don't accidentally share a bunch of random tabs. Okay. Okay, here we go. So here are some thoughts. Also, you know, what's the issue again? It was, here it is. So the first thing is, here's the example. What did I want to say about this example? I wanted to say, right, what would you desugar this closure to? So option one, you could imagine that this closure gets sort of internally desugared to something like this.
Mhm.
1 second.
Yes.
Okay, back now. So sorry. The reason I think this would I suspect there's some subtle and interesting problems that would arise that I'm overlooking right now, but let me explain why this would like mostly work.
Mhm.
We want two properties. We want to be able to return this, because this is a move closure, we want to be able to return it out from the stack frame. That's like
Mhm.
the whole point of a move closure, essentially, which
Okay.
means that it can't have any references into the stack, but it doesn't,
Uh,
because so normally taking a reference and capturing the reference would be bad, but in this case, it's borrowing the referent of this other reference. So like it's not into the stack, it's into borrowed memory.
mhm.
So in other words, the type of this thing would be like ammute string of, whatever this, or the type could be this, and therefore could be returned.
Mhm.
I think the more interesting uh, right,
Mhm.
signature might be something like this, because this gets at the idea that this needs to be returnable.
Mhm.
So right, so you would be able to return it, and the way that the borrow checker works these days, like you might think that this would make S be borrowed. There's another weird case where, right, if this was mute and you sort of did this, that would be legal with a move closure because there was a value in S, now there's not a value, now I'm putting a new value in.
Mhm.
It might not be legal with a non-move closure. Under some circumstances, it wouldn't be legal because S would not be borrowed, not moved. But in this
Mhm.
case, again, because we are passing through the reference, the borrow checker
Mhm.
has some rules to understand that it's okay to reassign S in that case.
Mhm.
So I think this would like mostly work as a desugaring.
My concern is when you look at like when you're trying to write the ampersand, sorry, when you try to write the line 14, you have the section where you deref s and dot x. I think this should be fine because we add another ampersand, kind of like we take the mute reference here. I'm worried depending on how we do it. Like we need to be careful that it doesn't think we're trying to move against dot s dot x here, which would again, I
So
think that.
I'm a little bit confused what you're saying. Sorry.
So when we write like when we look at line 14 and we look at like just the star s dot x part, I'm assuming when we do this in mer build, it will
Wait.
be able to realize that we're not really trying to move
Oh,
something out and take a reference,
this is line 14, you're saying. Uh,
like where you define the temp 0.
why would it, was it
And
the borrow checker or?
borrow checker, yeah, I think it would be the borrow checker, right? The error that we are looking through would be coming
I
from.
think it should work.
Okay.
You can simulate it.
I think I tried to do something similar in playground at that point, and that did not work. That's why I'm a little curious, but let's see.
Well, it's worth, yeah,
Yeah.
let's just make this an impl size. Something. Can you do that? I forget.
Do what?
Impl sized.
Oh, also, I don't know if your screen is sharing. I just realized that. Oh, yours is okay.
It is, right?
Okay.
Okay.
Yeah. It went on the other one, and yeah.
See if this works. Okay, so this is what, so now the test would be, we were doing something like, well, that's kind of the test. We're basically desugaring from
Mhm.
desugaring to this.
Mhm. Mhm. Yeah.
And then the key thing would be, let's just take a, be able to also do this. And it should all compile. Yeah.
Okay. Sounds good.
Now the question would be, how do we know? This is adding a sort of a lot of complexity in some sense, or it's like a new kind of, it's like a move ref borrow or something.
I don't. Okay, so the way I'm
No,
thinking is.
not a move ref borrow. It's just a mutable reference borrow. It's just that move doesn't always create move borrows.
I think what we can do is, and this might solve it solve the immutability problem as well, is instead of storing by value when we have a move closure, we store two pieces of information, which is like, this was what kind of borrow we determined based on capture analysis and what we are forcing it to be based on the capture clause being moved.
Right. I think what you would need, it's going to be a little bit, we have to think a little bit about how this works, but it's something like this. If you have, okay, you probably do regular capture analysis as if it were not move.
Mm-hmm.
And then you go over and anything which is captured by reference,
Mm-hmm.
but the place does not include, oh, this is going to be hard. I don't know. Let me think. Oh, well, it might actually work. I was going to say, but the place does not include a dereference,
Mm-hmm.
changes to a move. And if it
Mm-hmm.
does include a dereference, or in particular, a dereference of a reference,
Mm-hmm.
it just gets left alone. I
Well, if we have a dereference, it will be of some reference somewhere, right? Because we like,
No, it might be a deref of a box.
okay, fair.
And that's actually an interesting question. What happened? I think in the case of a box, you move the contents of the box. Like you want to take ownership of the thing.
Yeah, that makes sense from a box perspective, yes.
Now, whether there's a good question, which I don't know the answer to, which is like from an efficiency point of view, you probably would rather move the box than move the contents of the box, right? Like,
Yeah, like
pointer, you almost certainly don't want to move what the thing points at.
Yeah, wait, so if you move a box, it will move the box, right? And not the contents.
Well, that depends if we
Oh,
capture
if it's derived or not. Okay, yeah,
or
okay.
not, you know.
Yeah, no, that's fair.
I kind of think I think the rules for move closures are gonna need some. The rules for move closures in derefs are pretty interesting. I think they probably want to stop at derefs. If it's a move of a box, you
Mhm.
probably want to stop the move there and just take the whole box.
Okay, yeah.
Which is a little weird. Yeah,
What
it's not
I'm
obviously right. It's not obviously right. It's tricky.
what if we like remove all dangling derefs? Like by dangling, I just mean sorry, not dangling, trailing derefs. Like
That's not good enough.
uh
I mean, that
well
might,
I guess
but it doesn't like, it's not obviously right to me.
I'm thinking from a disjoint perspective at least. Derefs don't add anything to disjointness. From a move perspective, like reference itself will be copyable, so they aren't really stopping, they're technically getting moved. So like,
Well, that depends, but yeah, that's not true
so-
for, um, there's a subtle distinction if it's a in mute star, but it's not a bad idea. It might be the right rule. It's not always going to do the right thing. Where the right thing is, no rule will. Like it's a little bit subtle. What you actually
Mhm.
want to capture is.
So I had implemented trailing derefs because that was kind of like, okay, so the only things that were failing when I tried build lib standard were, well, the things that not only, but the things that were failing when I was trying to build lab standard were similar situations as my first example for this, which was like, we don't have a path, you just have a dereferenced uh, structure. So removing trailing derefs kind of fixed it. And what we ended up at was like with the unsafe issue where like the unsafe block issue that I shared earlier, where you're trying to dereference a raw pointer, which again, I think at some point we need to need to truncate those as well.
It's definitely wrong to dereference a raw pointer. That's just
Mhm.
definitely wrong. Like we have no reason to think that's safe until we execute the closure. Uh,
Mhm.
so we can't do that. Well, we can't do that at the point where we create the closure. And I think you are correct about moves. And the main reason I'm hesitating is, imagine you have like a box of a 2 tuple.
Mm-hmm.
You use x dot 0, and x dot 0 is some really big value, right? Like, and all you're doing is reading it. Like doing x dot 0 dot iter, like a big array, iter dot sum or something in your closure, and it's a move closure. We're now going to capture x dot 0, which is really inefficient, and it would have been much better if we had just captured x. And I don't know that there's like I don't think you'll ever get that right all the time. Like right now you have probably other inefficiencies where you capture a big root variable, but you only use one field of it, and it's silly to capture the whole thing. On the other side, though, at least the rule today is simple. Like I can easily predict exactly what it's going to do.
Yeah, that's again where my head is at. Like, should be something that's around migrations, and then let the user decide how they want to write the code, or do we go and make decisions that are confusing?
I think we want to design for what, like you said, what users would have wanted if there were no backwards compatibility concerns. The question is, I just don't know what I think that is.
Yeah, that's kind of my point as well. Is like my concern is a little around like if we add certain nuances to this and they're a little inconsistent places, that will, I don't know if, like, I feel like that might cause more problems than helping. So
yeah, I'm a little bit worried that if the rules are really complicated, people are going to get a reputation of being like, I have no way, I can't figure out what on earth is going on in move closures. So I always write it in this way that's very simple, like very annoying, but very clear. And
yeah,
I do see some value in saying, okay, move closures always capture the local variable. If that's not what you want, there's an idiom where you do, like, you know, this is what I do. I don't know. Other people might do their own ways.
Yeah, you create it outside and then you kind of just use that. Yeah.
And that's just the way it is. For non-move closures, that's a different story. And like, because mostly they take by reference anyway. But not exclusively. So like, it's not an entirely different story. But if they're not taking it by reference, it's because they're moving that value. Right? And so they're already moving it once. So you're changing from like, you move it when you create the closure and then again.
Sorry, can you repeat?
Okay, sorry, I'm jumping a little bit ahead, but let's use my tuple example, okay? If I had a non-move closure, and I did this, okay?
It will drop tuple today. Yes, the whole thing.
This is going to, what this is going to do, well, today what it's going to do is capture tuple by move. Well, let's make it like string or something so that it has a, I don't know, otherwise it might be a copy of it. And what I'm saying is, if we proposed a model where we said move always captures, is very simple, it's exactly like today, but if it's not a move closure, it tries to be smart and capture the most move, a more precise path. Maybe it omits trailing derefs, maybe it doesn't. But either way, then tomorrow it would capture tuple.0 by move, which is not great because size of tuple is 4 or whatever, but size of tuple.0 is big. However, it's not great, but when you call drop tuple.0, you're going to move
tuple in it.
you're moving it anyway. So like
Yeah.
now you're moving it twice instead of once. That's not great. But in
Wait,
contrast, like in the other example I had, we're moving it once instead of 0 times. You know,
but why am I moving tuple twice, 2 times tomorrow?
once when you make the closure and once when you execute the closure. So
Oh,
because it's going to be like,
oh, it's gonna desugar the thing first and then, yeah, okay, that makes sense.
yeah.
Yeah.
So there's another version where we say whenever you move, you always move the root variable. But
Yeah,
references are smart, and that's
mhm.
the nice thing about that is it's 100% backwards compatible. It's
Yes,
in some sense very predictable. It's
yes.
also a little weird that like if I
Mhm.
have that would mean that if I did this, this will not compile.
Sorry,
But if
can you
they were
explain that
borrows,
again? Yeah.
if they were
Oh, yes.
if they were borrows, it would compile, right?
Mhm.
That's okay. It's just a little like
Mhm.
that's the only place in Rust where like the path that you borrow and the path that you move, they sort of behave, they're like considered disjoint in all the same cases today. And now they would be different. So if we always made any move the local variable, and this would fail to compile.
Mhm.
But this would not. This is the point, right?
Mhm. Wait, you can drop things like that. Wait, that would just drop the reference,
Yeah,
right?
drop here is not important. The only drop is just some function that moves the value.
Mhm.
The point is
Okay.
it
Yeah.
makes a reference. And
Mhm.
because it's making a reference, we capture the full path, and so we consider them
Mhm.
disjoint. But here we don't make a reference, and so we don't consider them disjoint. And that I don't know,
Yeah.
that kind of galls me.
Yeah, I'm gonna take a quick look through when the RFCPR just to make sure if anyone ever brought move closures and if there was anything specific discussed around that.
At this point. Yeah, this seems like a surprising.
Yeah.
I don't know if it's surprising, but it's definitely an interesting interaction, and
Mhm.
I don't know what I think the right answer is. I definitely think it is unacceptable that this example.
Mhm.
I think it's unacceptable for this example to go from because it's going to compile either way. The difference is it's going to become the worst code ever.
Inefficient or not, yeah.
Yeah. And that means that like the idiomatic way to write this code is this.
Will be let tuple equals tuple. Yes.
And I think that's sort of unacceptable. That should not be the idiomatic way to write that code. That,
No, I agree with that point.
that should happen in some weird cases. I don't know. This doesn't feel sufficiently weird. Like you put the box in there because you wanted it to be cheap to move, probably.
Mhm.
And
Yeah, kind of. Yeah, it's funny. Like the first example that's of this RFC is one. Well, the second example is a move closure, but I don't know if this ever got brought up.
I feel move closures, it's actually less relevant that when you capture it, because I could be wrong, but my experience is I mean, it's not hard to imagine examples, but my experience is because the only reason to make a move closure is that you're going to return it from the function.
Mhm.
You don't as often have many of them reaching into the same data.
Yeah. Oh, I think there are a couple things at the around the end of the RFC when move was being discussed. So move closures always captured by move. We will continue to do so under this proposal. That makes so. Oh, uh, Yes, I think this exact exam kind of situation is being talked about, I guess.
I sort of
I'll
remember that we kicked a bunch of hard problems down the road, and maybe this was one of them. And now we're hitting it again. Got it.
it's like around the end of I haven't really read it, but I'll send.
But I do feel like this one is a really interesting example. This bad example,
Mhm,
because yeah, okay. So you could certainly make rules that say we will not move.
mhm,
Effectively, moving stops at derefs. Like
mhm,
it won't capture. They'll always move the pointer and not the reference. And I think the, that would, I guess that would, in some sense, if we just had that rule that moving just always truncates at a deref,
mhm.
um, that would fix, in some sense, our initial example.
I think that will fix a lot of things. Well, mostly because,
Yeah.
uh, yeah, I think a lot like we'll basically have a DREF as like the first rejection almost always, if especially if you're dealing with references, things that we cannot directly move. So,
It'll fix a lot of examples. It means some code won't. There would be slightly smarter rules that would make more code compile, but
mhm,
at the cost, perhaps, of being
mhm,
a little less predictable. I'm basically thinking that if you have a deref of a reference
mhm,
and a move closure,
mhm,
it's not obvious to me that you want to move the reference versus reborrowing the reference. But I'm not sure. I think I would be happy to make an issue, and for
mhm,
now, stop moves always at a deref.
mhm,
So we kind of run the capture algorithm as normal. Then
mhm,
we go, if it's move, we turn them all
mhm.
to and truncate them before any derefs.
Ah, mhm,
We'll always move the pointer.
mhm,
And that's just okay. I mean, it does mean that this example works. If you put this tuple in a box, the example doesn't work, but well, that's okay because we can sort of justify that by we chose
Okay.
like
Why would the tuple in a box? No. Oh yeah, yeah, we can't split them because yeah, both of them will try to capture it themselves. Yes.
right. You can't have it both ways. Like this example, either if you want this example to not move the array,
Mm-hmm.
then you can't have this example work when it's in a box. Like it just
Mm-hmm.
doesn't make so and I do think so yeah. So we say when you have a move closure, it moves every local variable or it moves things that are on the stack into, right? But
Mm-hmm.
things that are in pointers, it does not move. Like it
Mm-hmm.
moves the pointer, not the that's a like reasonable rule that I think one could
Yeah, I think
it's people will get confused, but it's
yes. Like I think we will need the nice error messaging around explaining this in compiler. Like,
yes, but nonetheless, I think it's a good starting point for us right now. So initial proposed rule is in move closures, we truncate or we capture the most precise path that is used, which is on the stack.
yeah.
So in effect, we truncate captured paths before a deref. And there's possible extension, which is to convert a and mute star x, or is to sometimes capture by reference if the place is only used by reference and it is a deref, it is a reborrow,
Mm-hmm.
a deref of a reference, but may have complex lifetime interactions and is hard to explain. And I doubt that I've even explained it to you, much less the user
I
who's trying to understand it.
I have some ideas. Yes, it makes sense to some degree. Yes.
Yeah,
Yeah.
I'm a little bit afraid of it too, because, I mean, besides the fact that it's hard to explain, I'll just write down the example, one of the examples that bothers me, so that I have it for the future. But if you, I think it's okay, because I think this code also does not compile today. But if you had something like this, today this would not compile
Mm-hmm.
because you're going to capture S,
Mm-hmm.
but that is a reference to the stack, and we're returning it outside, so
Mm.
the
Yes.
lifetime
That makes sense.
won't work. And if by this rule, what I'm getting at here is that what would happen with my extension is that we would, or maybe drop isn't the right. Let me just, yeah, let's do this. We would like see that we have reborrowed S, and so we would kind of capture ampersand star S, which, yeah, I guess it's fine. Which would basically run into the same error, essentially, because the lifetime of that new reference that we're now capturing is still tied to P in the end.
Yeah.
Which
Like,
is,
yeah, we can't run away from these things that are on that stack. Yeah.
right. So this won't compile, but it wouldn't have compiled before, so that's okay. I guess I think there might be an example like this where the right thing to do is to capture by move, but you can't tell that unless you trace out all the things that the reference refers to, which we don't know. So like,
Mhm. I
that's
think
that's what I'm wondering, and I can't think of what it would be right now. But
okay. I think if this goes in, this will also fix the problem with. I don't know if this will fix the problem with the unsafe pointer, but we can just remove derefs if we are starting off with an unsafe pointer anywhere.
fix that, because that requires a deref. So
Sorry.
that it should fix the unsafe pointer.
Well, it will fix the unsafe pointer if it's a move closure, right? It won't fix unsafe derefs if it was like if you're capturing an unsafe deref
I
without,
see. Yes, you're correct. We have to do it. We have to have an extra rule.
which is like if it's an unsafe pointer and there are derefs truncated at the unsafe pointer.
Yep. And it occurs to me that there is some other case we have to worry about with unsafe code,
Oh.
which I don't know if there's a test for it, but we should make one.
Yeah, I think we need still a lot more test cases for this. Like the more of like after enabling the feature on the compiler, ran into a couple interesting things.
So if you have fields like this,
Mm-hmm.
because it's wrapper packed, this is at offset 1,
Mm-hmm.
which is not a valid, not an aligned memory address.
Mm-hmm.
So this code, well, actually, it doesn't matter. Hold on a second. So this code is unsafe because we don't know if the field has an aligned address or not. And maybe we wrote it with an unsafe keyword because somehow the user believes that it's aligned. And the point is, just like with unsafe deref, if this is occurring inside a closure, then we cannot capture .x at the point of closure creation. We must capture foo or whatever.
Right.
So it's basically exactly the same thing. There are some places that are unsafe to use, and we have to stop those points.
Wait, so when you do an ampersand foo here, you get an raw pointer. You should still get like I would have assumed that would give you.
No, this
a
gives you a reference.
Yeah.
The problem is
no. I'm talking about you wrote the ampersand foo. Like I'm thinking more from a type perspective. Like the type of ampersand foo will still be a reference to foo, right? Like an immutable reference to foo.
Yeah.
I'm thinking more from a code perspective of how we can figure it out that we need to capture foo.
Oh,
And
so the path you'll see, so in your code,
Mhm.
you'll see a place like foo x,
Mhm.
and the problem, the way you know is if you have a field projection where the field is defined in a repr pact.
Mhm.
I think you should just file an issue for this. Don't try to implement it now. But
Okay.
I can go look later and give you like a pointer to write some code that tells you how to check for this.
As long as like there's like is the wrapper pack reflected in the type information of the ADT, like we'll have like a foo, because
Yeah,
if
you can
that's
add
like it,
def what it's
yeah,
representing.
yeah, that's okay. Yeah, that's what I'm thinking. All right, I'll add a issue for this.
It's a
And
similar case. Oof, this is this feature. I think it's worth
yeah,
it, but it's more complex than
yeah, like I
appreciate.
feel like the I think a couple meetings before it was just like, okay, we have the more thing left, and the moment that got enabled, it's just like, all right, fireworks everywhere.
Yeah,
Just
I'm a little bit
not
like
the good thing. Yeah,
I'm distressed by the move rules. They're more.
yeah,
Uh,
yeah.
I'm
Uh,
not. Yet, I'm kind of happy with our deref rule. I think we found a. This is like I could
mhm,
imagine explaining it, but it's definitely more complex than I would like.
mhm. Uh, yeah, okay. I have like I'll probably drop in about 5 to 10
Yeah,
minutes.
I should drop.
What? Yeah,
This is
and
the only
wait.
time to lunch. If you have
Yeah,
another question, let's do it.
yeah. I think the only thing now left is our patterns. Well, I won't use the word only, but one of the I guess main things that are left now are patterns. Uh, like wildcard patterns. So I'm assuming we just go like I didn't get a chance with like all the small these things that came up the last couple of days to dig too deep, but we probably want to start using place builder somewhere. But I feel like that code is still fairly complicated to before I go make changes everywhere. Like we make all those changes. I kind of want to discuss uh, if there are parts that like if there's some main parts that should be using place builder and some that we can leave at place and not refactor like all
Um,
of that code.
sorry, 1 second. Uh, which code do you not want to refactor?
Oh, like the
Just,
more
I
pattern one, right?
I got distracted again. The mirror building, the
Yeah,
fact
the
that
pat
mirror stuff uses place builder. That's what you're talking about.
yeah, yeah, like using what is it called? And when we build patterns using place builder everywhere
Yeah,
instead of
but we don't, right? We use
we
place.
we use place. So I'm debating how much do we want to use like so we had two things going on. One thing we were discussing was, does it make sense to just use like consume the place in its entirety if it appears in a pattern? It's
Yep.
an easy fix. I am trying to like just look away in the sense that I don't like I'm trying to think more from a perspective again what it would have been if this feature was available from start and not something that's just easy for us to do. Which makes me wonder that just for symmetry inside and outside of closure, I feel like we should go and do it, implement do the refactoring and basically implement precise capture there. But I haven't looked too much into how to like what all needs to be changed because there's a bunch of large files and I don't want to like refactor everything and realize still something
So
might be.
to be clear, we're talking about this as like a separate PR, right? Not part of the part.
No, yeah, no, that's gonna make this one already.
And I think that if the question is what would we do from first principles,
Hmm.
I tend to agree that if the code compiles outside of a closure, ideally it would compile when you put in
Inside.
closures, more or less, right?
Hmm.
So like
Hmm.
that means that we would capture more precisely.
Hmm.
I don't know how hard that refactoring is going to be. It doesn't,
Like,
it seems, I mean, it'll be, it's like medium is my guess. You know, it's
mhm.
it's work. It's
Yeah,
probably
it's going.
mostly mechanical-ish. The biggest concern I have is like maybe it turns out that the code runs really slow now because it's got a lot of vectors instead of intern thing. But
Hmm.
it's not obviously true because we'll do probably less interning. I don't know.
Hmm.
It might need some. That could be a problem. Um, I feel like it's low. That said, I feel like it's relatively low priority. I would
Uh,
rather energy is invested in working out this move problems, for example, and
uh,
thinking about migration.
mhm. I do not know if it's entirely low priority because it's not that if we have all wildcards that it fails. It will fail for any wildcard.
Well, define fail. I mean, it captures a overly broad path, right?
No, I'm sorry, I'm confused. What do you mean by overly broad path there?
So what
Like
I meant
if
by
I,
my low priority assumption was saying that if in the meantime we added a false read, so that
mhm.
capture,
Oh, okay, I see. Yes, yes, that one.
I think I would rather have that and work to get the end-to-end solution.
Mhm.
And
Okay,
then it's like a pretty orthogonal thing to come back and make it a little more precise in one case. But I'm more concerned about like what problems are going to crop up when we try to do migration or, you know,
okay, that sounds good to me. Like, yeah,
yeah,
okay. So hopefully dealing with this move is not going to be that bad. Like it should be a couple lines of fix then.
yeah, it doesn't seem too bad. Migration will be interesting. That's
Yes.
grungy.
Sorry, that's going to be?
It's going to be grungy. Like
Yes.
it's conceptually simple. Unfortunately, the way you
Hmm.
have to implement this stuff, it basically comes down to like textual diffs from what I know.
Hmm.
Uh, so we have to,
Oh.
it's not like we can edit the AST inside the compiler and it generates a nice
Hmm.
thing. Like
Nice.
it
Hmm.
can be kind of a pain in the neck that way.
Hmm.
Maybe there's some good techniques. We should ping Esteban. He's the master of this
Okay.
stuff. Um,
Okay. Yeah. Diagnostics are also sort of in work. So just to kind of give you an update. So there are two PRs currently in work on our end. So Roxanne has this one going where we basically, when we report FN mute, FN once and all that, we report precise paths there. So that's sort of starting to get in, be in works. And the other one for diagnostic that's going around is, so it's possible, and we have discussed this before, is like, let's say we have this min capture situation where you read P, but you modify P.x in a closure. So like the error message based on how things would be today is like P is used as a mutable borrow, but it's like, it could be confusing if, which like you might like the path and the reason for a mutable borrow might be two different expert IDs and like two different spans. So storing that information is also sort of in the works.
cool. Yeah, I remember we talked
Yeah.
about.
So
Yeah, so those are good examples of things I would prioritize over top of uh,
yeah,
match.
so that's in the works, and Jenny and Logan are also working on what's it called? Getting rid of like closure captures and like the old data structures from the compiler.
Awesome, man. You guys are like gonna be rusty hackers galore here. We need to,
That'll be that'll be nice.
we need to keep you working on Rusty after this is done. All right.
That'll be nice. Yeah. It's funny, like our school is moving towards teaching one of our courses in Rust, so that's going to be interesting next term.
Oh yeah.
Yeah, our perf course got converted from C++ C to Rust, so looking forward to how that goes. All right, I'm gonna hop off
Yep. I'm gonna go.
and I have a meeting starting soon. All right, see ya.
Bye.